Hi, everyone. Welcome back. This is part of my ongoing series on BESS Performance Engineering, where I share the frameworks, tools, and lessons learned from years of working on battery energy storage assets and complex industrial equipment. In this module, we're going to kick off with the fundamentals, BESS availability. Before we can talk about how to measure performance, we need to be sure that we're all speaking the same language because availability means different things to different people. Now, I'd like to draw a parallel with manufacturing. I got a background in industrial automation, and in manufacturing, we measure performance of a system using overall equipment effectiveness, OEE. And that's a term that combines like the availability of the equipment, the performance of the equipment, maybe how fast it's running, how many parts can it make, and also are the part any good? What's the quality? So I'd like to coin like the term OBE, overall battery efficiency, or overall battery effectiveness, and that would be a term that comprise equipment availability, operational availability, power availability, and then the energy capacity. So is the BESS on, off? Yes. Can it deliver power when it asks? Yes, no. What was the shortfall? Will we be able to deliver so much power? And then what's the overall state of health? So we'll kind of use that term going forward, OBE, as the combination of all this different availability. Now, before we get into the different availability, I want to kind of review quickly like the capacity types, because often when we describe availability, we might convert it to percent, and it's percent of a certain megawatt or megawatt hour. So it's good to standardize it in the terms. We're going to talk about contracted availability and installed availability, because on a site there's always the installed capacity in the power or energy. That's how much like you could extract from the site, like if everything was running at kind of its fullest kind of capacity. And then there's always something that's lower, that's the contracted or the nameplate capacity. And the difference is like the green on this chart is like the overbuild. So in this example, we have 10% overbuild on energy capacity between contracted and installed, always resulting in an additional kind of overbuild in power. So there's a bit more power. And you can see over the years, there's different way to deal with this capacities over time, depending on maybe your tolling agreement, the market you're in, the type of BESS. You could be maintaining the contracted energy the same every year for the life of the project, where the installed capacity goes down. So the buffer, that overbuild buffer, goes down and then eventually gets augmented maybe back. You add more batteries, but you're always staying on top of a fixed value. Or you could assume that the nameplate, your contracted value every year goes down, meaning like maybe in your financial model, what you're expecting. So maybe you don't, in those scenarios, you don't call it contracted, maybe you call it nameplate, but still the same principle. Is a certain value that degrades over time, but there's always going to be a buffer. There's always going to be a little more than what maybe you call contracted value. So the first out of our four main availabilities that make up the OBE is equipment availability. So we're going to look at this availability across four different dimensions: the granularity, the coverage, the accuracy, and any blind spots. Different methods of measuring availability have different, there's pros and cons, they have strengths and weaknesses. So granularity means like how granular can you like measure it to 0.1% or 0.1 megawatts. In the case of equipment availability, it's pretty coarse, like it's on off at the equipment level. So if you only had like 10 pieces of equipment, every one PCS that goes down is 10%. So that would not really maybe be the greatest way to measure. You can't really measure that higher granularity than this with just equipment availability. Coverage, is this covering all operating kind of intervals? There is some type of availability that you can only measure when you actually are operating, like meaning you're delivering power to the grid, or you absorbing power from the grid. In this case, equipment availability is kind of 24/7. All intervals, we have a status from the equipment is pretty high. The accuracy is very high. This is like a pretty accurate signal you get from the equipment. You can measure voltage at a certain terminal to see if contactors are on or off. Equipment are pretty reliably broadcasting their status if there's any faults. So in general, this kind of signals and metrics are fairly highly accurate. Now, they have blind spots. So equipment availability doesn't measure performance much. So it doesn't measure things like imbalance. If you have 10 PCSs, but one is near empty, its batteries are near a very low SOC, the other ones are not. At some point, you're not going to be able to deliver the power from that PCS that doesn't have batteries with any state of charge in it. So your power availability will go down, but the equipment will still be operational. So you might still be reporting 100% availability, even though you cannot deliver power. So we'll call this a blind spot. This blind spot based on like derates, like temperature derates that different pieces of equipment could be derating, but they could still be on and operational. The primary unit for this is like percent. Typically, we just count how many equipment is operational, and we do ratios. So often when you do equipment availability, you get a percent, and then normalize them to a constant kind of unit. So it could be megawatts, or it's always going to be often megawatts, and it could be megawatts, percent of megawatts installed, or percent of megawatts contracted. So each piece of equipment, you'll need to figure out what's its nominal megawatts, so kind of contribution to the total megawatts. So if you have 10 pieces of equipment, your site is 10, like 100 megawatts contracted, then maybe each piece of equipment contributes to 10 megawatt out of 100 megawatts. But if the installed capacity is 110 megawatts, there's a bit more, then each pieces could actually contribute like 11 megawatts. So that's also an important concept. Now, to layer on top of equipment availability, which has some blind spots, we often add operational availability, which is like something you can measure when you're operating, meaning when you're actually sending a set point to the BESS to deliver 50 megawatt. If the BESS cannot deliver the 50 megawatt, then you can measure the shortfall, and what it delivers, it's real availability at this time. So the granularity is really high. We typically measure at the meter, like how much megawatts are delivered. The coverage pretty low because you can only do this during operation. So if it's a 2-hour BESS, like 2 hours of discharging, 3 hours of charging a day, that's pretty low coverage. The rest of the time, you can't really use this methodology. The accuracy is very high. Like if you have a set point of 100 and you're getting 90, that's 90%. That's pretty easy to measure. But there could be some blind spots. Obviously, all time where you're not dispatching, you're not seeing. You don't know what the operational availability is. There's also times where you might be getting dispatched less because you're aware of an unavailability. So if you're aware that your plant cannot perform at 100 megawatt, only 90, you might send a 90 megawatt set point, and you're going to meet this. So the operational availability in this case will not detect that there is a shortfall because you're only sending a 90 megawatt set point. There's also like the external controls can also detect that there's a shortfall and then change your set point dynamically to try to kind of test what's the capability. So the set point could be actually lower than the contracted value. So there's quite a few blind spots, but since it's fairly easy to measure and it's quite accurate, it should be layered on top of equipment availability. And that's going to be measured in megawatts and only in percent of megawatt contracted. The third one is power availability. And that's kind of the most kind of robust one from a covering all 24/7 kind of all your intervals. it's quite granular because it's going to be given in megawatts. The challenge with power availability is the accuracy. It needs to be calculated because the equipment is not operating, and you need to estimate its capability if it was to be dispatched to deliver the power. And it's going to be based on various metrics from different pieces of equipment. Of like each battery is going to report their current limits, their power capability, and you're going to have to aggregate this, model this at the inverter level, and then report this up at the BESS level. You might have to apply some limits. So it's quite a bit involved in calculating this. And it could be corner cases where your models, your power availability calculation is actually not accurate. So again, this is going to have to be layered on the other ones, the other two, but this is quite important to cover all these times of where you're not operating, and you still need to know what the equipment would be capable beyond just is the equipment on or off. So if this will capture things like imbalance, if you had batteries that were fully empty but the equipment was on, this will capture it fairly accurately. Now this is going to be primary unit megawatt. It could be actually trimmed in percent of megawatt, percent of installed capacity, or percent of contracted capacity. And the fourth one is energy availability. This is typically not a real-time metric, but if your BESS at a state-up health issue, let's say all the batteries are degraded, you might want to layer the capacity on top of this. So instead of 100 megawatt BESS, it's actually only 80 because all the batteries are only 80% of their expected energy capacity. And this will be for every time interval, so pretty good coverage. But that estimate might only be updated annually, or when there's a capacity shortfall that you test. So this might be coarse kind of in terms of how often you can actually adjust your energy capacity, your energy availability. If you were to try to calculate it, the accuracy might be low to medium, where it's kind of odd to always know the state of health of an asset. And you could, if this was done for performance engineering, you could probably estimate it with some state of charge kind of algorithm and figure out usable capacity and what's kind of maybe trapped energy. That could be a good way. But if this was for contractual KPI, like the only robust way to actually measure it would be to do a capacity test. But again, this should be layered on top of the others. So at the end, you got a robust, comprehensive kind of or like overall battery effectiveness kind of metrics. So here's a bit of a recap. Each of these different type of availability, they got strengths and weaknesses, but you can layer them onto each other and then have a comprehensive kind of overall kind of availability numbers. So if you find yourself with a contract or measuring on the one type, look at the other type of availability and see if you can just kind of add them to your overall availability calculation. And always remember, when you deliver these numbers in percent, always clarify if it's percent of contracted value and what that value is, because it might change over time. And if it's percent of installed, then make sure you also know what's this installed capacity, which might be your latest capacity test. That's always quite important. And then when you talk about capacity, that could be confused for energy or power capacity. In the utility industry, the capacity term is often used for megawatts for power, but in battery energy storage, we'll often use capacity as an energy capacity. So also be mindful of like who you're talking to, and maybe always mention the term energy or power. So just to recap, like our overall battery effectiveness is going to be kind of all these four different availability kind of layered, and often we'll take the weakest, the minimum of all four. So we've covered the fundamentals of BESS availability in general. In our next session, we'll do a deeper dive on equipment availability. So stay tuned. We'll see you in the next video.